Good morning again. I hope you all well and healthy. I'm so glad to be here. Thank you very much. A few words about me. I am Maria-Anastasia, and as Marco said, a few days ago I have been awarded as a Microsoft Azure MVP. Moreover, I am studying computer engineering and informatics at the University of Patras here in Greece, and I work as a software engineer at the Team Candy. I am also a Gold Microsoft Learn Student Ambassador and robotics teacher. And finally, I love to give presentations about Azure IoT, and I am a co-host of the IoT Live Twitch live stream. We are live almost every Tuesday night, so we can find us on Twitch. So now I think that we now go to see with what we are going to deal with today. Today we will talk about these Microsoft Learn courses, the Microsoft Azure IoT Strategy and Solutions, Introduction to Azure IoT Hub, Learn how to manage IoT devices as an IT admin, and the Introduction to Azure IoT Edge. And this is our journey for today. So today we will learn what the IoT is. Then we'll understand what Azure IoT is and how it works. After that, we're going to identify ways you can use Azure IoT. Then we will examine the Microsoft vision for Azure IoT. And finally, we will see a Christmas IoT application. So let's get started. First of all, Internet of Things is the communication network of many devices, as well as any object that incorporates electronic means, software, sensors, and network connectivity to allow data, connection, and exchange. These sensors are typically embedded in monitoring devices, and these devices, known as IoT devices, have some processing power to control communications. The stream of data they generate is known as telemetry. The most used telemetry values, for example, are temperature, humidity, location, pressure, etc. Simply, IoT is the connection of all electronic devices to each other as a local area network or with the ability to connect to the internet. The term things now is not strictly associated with certain products. It refers to a wide variety of devices. The main feature of all of them is the connection between each other in order for the user to be able to control them from a computer or a mobile phone. When we talk about IoT, we refer both to machine-to-machine communication. For example, a sensor realized that it's night and sends a signal to the shutters to close, as well as in the human-to-machine communication. For example, a person via his phone closes the shutters. Why is IoT so helpful? IoT help us in our daily life, and on the other hand, it helps us in tasks that are very, very difficult to take place without it. Moreover, once data is collected, it becomes possible to analyze it to gain meaningful insights. These insights can help increase efficiency, reduce waste, or lower costs. Alternatively, might make smart spaces more secure because it will be more possible from IT employees to understand the data and detect security gaps. Why I deal with IoT? First of all, it's very fun to deal with IoT. Secondly, as you can see, the total installed base of Internet of Things connected devices worldwide is projected to amount to 30 billion units by 2025, a sharp jump from the 14 billion units that are expected in 2021. So, how to start dealing with IoT? First, you have to understand how IoT systems work. First of all, sensors. Here in our slides, sensors detect a physical property and send it to microcontrollers. Here is a Arduino, for example, and here is another microprocessor or microcontroller. Then microcontrollers send this data to the gateway. Here we have a Raspberry Pi to be our gateway. And finally, the Raspberry Pi sends the data to Azure IoT. In the cloud, a resource known as an IoT hub collects the data and processes it. The hub might also communicate back to the devices, perhaps changing settings or parameters. Thus, we can inform about this data from our mobiles, for example, or from our laptops. These are the must-haves you need to start dealing with IoT. You can screenshot this slide, or you can find it in my blog. The must-haves are these, and first of all, you have to have a microcontroller, sensors, breadboard and cables, basic knowledge of electronics, basic knowledge of programming, Wi-Fi connectivity, of course, a gateway like Raspberry Pi, a server like Azure, and of course, patient. So here we are here, and now we are going here. And we are going to speak about Azure. First of all, Microsoft Azure is cloud platform that has more than 200 products and cloud services designed to help us bring new solutions to life and to solve today's challenges. We can build, run, and manage applications across multiple clouds, on premises and at the edge, with the tools and frameworks you like. Microsoft has entered the IoT sector many years ago with a strong cloud-based offering, using pre-configured modules which enable a rapid deployment of an IoT solution. The service includes device-specific SDKs for Visual Studio, support for Linux and Windows-based devices, and a cloud-based service which can quickly and reliably scale for a few sensors to millions of simultaneously connected devices with secure. Why I'm going to choose Azure? Azure IoT can help organizations across all industries to solve a common set of business challenges, to fuel innovation and digital transformation. Such challenges are complexity, cost, and security. Also, Azure IoT has excellent support, such as the Microsoft employees and the huge community it has. What does an Azure IoT architecture look like? The diagram illustrates a recommended Azure IoT solution architecture. An IoT application consists of the following subsystems. First of all, things, physical things with embedded sensors that are connected to the internet. Secondly, insights, the results from processing and analyzing the data. And next, actions, the automated or manual response to the insights. Moreover, we have devices here that can securely register with the cloud and send telemetry data. Alternatively, multiple devices might communicate locally with an edge gateway device. Then we have a cloud gateway service or hub to securely read the incoming data and provide some device management capabilities. Then we have stream processors that consume the telemetry data, integrate with business processes, and place the data in the storage. And finally, we have a user interface to visualize data and enable easy device management. So let's go to see now some applications. Many industries can benefit by innovating with IoT. Examples of industries include manufacturing, transportation and logistics, energy and natural resources, agriculture, retail, government, healthcare, finance and services, smart buildings and smart cities. But IoT is even on us, as you can imagine and as you can see. So now we're going to see which Azure IoT services we can use. The first two services are the main Azure IoT services for IoT, these two, but there are more services for IoT. So let's take a look. Let's begin with the two main services. First of all, Azure IoT Hub. Azure IoT Hub provides secure and reliable communication between our IoT application and the devices it manages. That is, Azure IoT Hub provides a cloud-hosted solution back-end to connect virtually any device. Through the Azure IoT Hub, you can see various information to monitor your system and make your own custom solutions for how you want these to look from scratch. Azure IoT Hub provides us with an extremely safe, it was the previous slide. Azure IoT Hub provides us with an extremely safe and reliable communication between of the application and the devices it manages. Second, allows two-way communication, as you can see in the picture. Next, it's a platform as a service solution. Integrates with many Azure services, that is extremely important. And next, has many programmable SDKs for popular languages like C, C#, Java, Python, Node.js, etc. And finally, Azure IoT Hub supports multiple protocols like HTTP, MQTT, etc. Now we can see Azure IoT Central. And Azure IoT Central is similar to Azure IoT Hub, with the difference that IoT Central is not a custom solution. This solution offers you communication with your devices too, but has specific templates. It's essentially built on Azure IoT Hub, though. Azure IoT Central, it provides us with an extremely safe and reliable communication between of the application and the devices it manages to. Allows two-way communication, but it's a software as a service solution and not platform as a service solution. Provides specific templates, as I told you before, and for this reason, it doesn't require deep technical knowledge, so it's more easy. As we know, when it comes to data transfer and storage, we need to take the necessary measures to protect them. I think that you can understand that, especially in the Internet of Things, it's very important to protect our data and our systems, because violating them can be very, very critical. Think about what can happen if someone violated the system we have in our house. He could break into the house or have information about our houses. And that's why it's necessary to use cloud system that is very reliable, such as Microsoft Azure. Microsoft Azure Sphere is a solution for creating devices with high security. Azure Sphere is a secure end-to-end IoT solution which contains certified chips, as you can see here, and Azure Sphere OS based on Linux, and of course Azure Security Service Trust Device to Cloud Communication. Azure Sphere certified chips include building Microsoft security technology to provide connectivity. Azure Sphere, Azure Sphere OS adds layers of protection and ongoing security updates to create a trustworthy platform. Azure Sphere Security Service brokers trust for device-to-cloud communication, detects threats, and renews IoT device security. And Microsoft security experts monitor and emerging threats, design updates. Now, Azure Sphere can be combined with Azure IoT Central, such as with Azure IoT Hub. Now we're going to see the Azure Device Provisioning Service, DPS. This service is an auxiliary service for the IoT Hub in which no human intervention is required, allowing millions of devices to connect in a safe way. And now we have Azure IoT Edge devices. Azure IoT Edge is a combination of cloud service and a runtime on the device. It's based on the Azure IoT Hub, and this service is intended for those who want to analyze most of the device data locally instead of the cloud. either due to network issues or other problems. IoT allows you to first, because it can run some functions on the device spends less time communicating with the cloud. Second, it provides cloud interface and runtime module, which allows us to manage our devices through the IoT hub. And third, it allows the use of Docker-compatible containers. Next, allows access to certified hardware, Linux or Windows, devices that supports container engines, and allows us to develop models that have been built and trained in the cloud and runs them on devices. IoT use the model to process data locally and respond quickly to the event. Allows us to use language such as C, C#, Java, Node.js, Python, etc. IoT edge devices record a large amount of data, but you usually only need a small portion of this data for further analysis. Due to this, IoT edge reduce costs by allowing only the data portion needed to be shipped. Moreover, often IoT devices need to work offline with the cloud, and IoT Edge automatically syncs the latest device status as soon as it's connected. IoT Edge provides security in a number of ways, such as in partnership with the IoT Hub. We can ensure that only the right device can communicate with each other and that they have the right software installed. IoT Edge can offer added security by integrating with Azure Security Center, and Edge can protect personal data. This data can be declared before being sent to the cloud, thus providing better protection for everyone's privacy. Finally, it acts as a gateway and thus provides connectivity and analytics to IoT devices that would not otherwise have these capabilities. And the last one is the availability of third-party modules, that we may use third-party modules from the Azure Marketplace. Now we can continue with IoT data analysis. And we have three solutions here: Azure Time Series Insights, that enables the display of anomalies in data, which can be difficult to detect visually. Thus, it automates the problem-solving process. Then we have Azure Maps, that enables the the display of vehicle locations on the map and the calculation of the optimal route with many parameters and preferences. And the Azure Maps includes a number of features for managing geopolitical data. For IoT applications, useful features include traffic, routing, weather, and search. And finally, we have Azure Digital Twins that enables the creation of digital models. Digital twins can be used to create solutions that manage system operations more efficiently. These environments could be building factories, farms, energy networks, railways, stadiums, and more, even entire cities. Here we have IoT Hub SDKs, and we have Azure IoT Device SDKs, Azure IoT Service SDKs, provisioning device SDKs, and provisioning service SDKs. Azure IoT device SDKs contain code for convenience of creating applications that are connected and managed from the IoT Hub. Azure IoT Service SDKs contain code to facilitate the creation of applications that interact directly with the IoT Hub for device management and security. Provisioning device SDKs enable us to create applications running on our IoT devices, and provisioning service SDKs enable us to create backend applications to manage our registrations. This is a summary table I have made to help you remember the services that it's used in the IoT. Here is the two main services. Here is the services for for the security. Here is Azure IoT. Here are the services for the data analysis, and here are the services for the IoT Hub SDKs. And here is one more summary table to help you, to help you remember all these things. IoT Hub is the main solution, and it's a platform as a service solution. IoT Central is an easier way to use IoT Hub, and it's a software as a service solution. Next, we have Sphere, which is for security, and it has MCU and OS. Then we have DPS for security and Security Center for security too. Azure IoT Edge that has modules, runtime and cloud interface. Then we have Time Series Insights for data, maps for data too, and digital twins for data and graphs. And last but not least, SDKs that is programmable. Now we have just finished this summary, and we have completed a quarter of Azure's IoT learning path. So you can go and learn these courses on your own, and then you can continue with the other courses as well. Now these are some resources here. Of course, our Microsoft Learn. Then we have GitHub, that is a great tool for developers. Then we have SparkFun, Adafruit, and Instructables that are great websites for IoT and electronics projects. And here is my own blog about IoT. You can visit it and be informed about Azure IoT, and for robotics, Arduino, Raspberry, etc. Now we have not very much time for a demo, but because Christmas is coming, I want to tell you one Christmas idea. You can build a Christmas tree light on your own. All that you will need is one Raspberry Pi or one Arduino and ESP32, because Arduino it's not connected with the internet. You will need an ESP32 to connect with the internet. Then you will need your Christmas lights. Then you will need a relay, but you have to be careful because when you will connect Christmas lights with the relay, you will have to be very, very careful. And if you don't know about electronics, maybe you have someone that knows about relays. Then you will have cables, breadboard, and of course Azure IoT. Here is how Arduino connects with a relay. It's very, very easy. And here is how Arduino connects with ESP32 or ESP82. It's quite same. So I will close this event so we can continue with Q&A. You can find me here. This link has all of my links.